Okay, this video is going to run through the solutions for a previous test. Let's look at the first question. It's asking you which of these functions, or which of these mapping functions are functions, right? And give reasons for your answer. So let's go back to what do we know about functions. They have to pass the vertical line test, which means for every x value, right, there's only one y value. So that's why this good old quadratic parabola is indeed a function, whereas this relation here, this is not a function, because for this one x value here, you can have 1 and then a second y value. So that means that's not a function. So if we then look over here, each x value has its own individual y value. Now, yes, both of these have a 3, but that's okay. So this one is indeed a function. Whereas over here, you can see this for one x value, it has 2 y values, so that one is not a function. Okay, explain why the following relation is not a function, and that's because from here, when we square a number, I can actually have the same value but for 2 different values of y. So for example, if y was equal to, let's take 5, okay, we then have x equals 5 minus 1, all squared take 2, and we can get 16 take 2 is 14. But what if, right, this thing in here, that's 4, but what if it was negative 4? So in other words, if y was minus 3, we could end up with minus 3 take 1 squared take 2, and that gives me minus 4 squared take 2, which is 16, which also gives me 14. So basically, I can have 2 values for the same value of x, I can have 2 values for y, and that breaches our definition of a function. Okay, so that's why not a function, because we've got 2 values there. Okay, next one. So good old function notation. Remember what this means is that go to your f function up here, and wherever x is, we're going to replace it with 2. So f of 2 becomes minus 2 times 2 minus, I'm going to use brackets anyway, minus 2 squared plus 3. So hopefully you could do this probably quicker without using a calculator, but if you have to, by all means, feel free. So minus 8 plus 3 minus 5. Right, same thing, but with a negative now. So we're still going to go back to our f function, and wherever the x is, we're replacing it with a negative 3. So instead of 2 times x, it's 2 times negative 3, right? Minus, instead of x squared, it's minus 3 squared plus 3. Negative 2 times negative 2 is 6, minus, now minus 3 squared is 9. So if you are using your calculator, please be careful with that. 6 take 9 is minus 3 plus 3 is 0. So this is actually a special point. Okay, this is the coordinate minus 3, 0, and that is in fact an x-intercept. We know them very well. Okay, f of 2 take a. So once again, we're going to go back to our function, and this time wherever x is, instead of replacing it with 2 or 3 or minus 3, whatever, we're replacing it with 2 take a. So it's minus 2 times 2 take a minus x squared, which is 2 take a squared, plus 3. And now your job is just to tidy that up. So let's expand these brackets. Minus 2 times 2 is minus 4. Negative times a negative is a positive. I am going to expand my brackets first, okay, before timesing through by that minus. So remember, 2 take a times 2 take a, 2 2's are 4, 2 times minus a is minus 2a, we get another minus 2a, and then negative a times negative a is positive a squared. So would I like you to be able to go straight to this? Sure, but if you can't, then just do what I did at the side and expand it using, right, FOIL, okay? Gather our like terms, minus 4 plus 2a. We're taking 4, we take 4a, so that becomes plus 4a, and we're taking a squared plus 3. Gather your like terms. And there we have it. Hopefully, if I've made any errors, you can catch them, but I'm just trying to do this quickly. All right, let's have a look at question 4. Determine the domain. So remember, your domain is all of your x values, and the range are all of your y values. So let's start with the domain. We can see that, actually, we'll do it color coding. How about that? So we'll change that to our y. Okay, so back to our x, we can see here that it's going from 1 all the way onwards, and it can actually be 1, and it's also going from -1 all the way there. So for our domain, we're going to say that x can be less than or equal to -1, and it can be greater than or equal to +1. Now for our range, we're talking about our y value, so when y is 0, we've got a value for x, and so on and so on. So basically, y exists for any value. So y can be any value whatsoever. Hopefully you're playing along with this and you've been getting full marks so far. Okay, part 2. So this time, the closed dot, we know it means it can be that value, and the open dot means it's up to there, but not actually being. So let's chuck out, look at our x values first. So it's here, 5, and then 4. So basically we want to say that x is in between 4 and -5. So it's less than 4, but it's greater than or equal to -5. Remember, the equal to is because of that closed dot. So there's our y, there's our x. Now our y values, it's going from 4 and down here -4. So this time we're going to say the y has to be less than 4, but greater than or equal to -4. And let's keep on going. Okay, what's this one? So when we look at this, you can draw that on your graphics calculator if you want to, but the first thing that we're looking at is this thing here, and we know that the denominator cannot equal 0, because if it equals 0, then you're dividing by 0, and that's no good. Okay, but let's go and have a look at our calculator first. So we're going to graph that. We're going to go menu 5. Oh, we've got a few graphs there. Okay, x take 2 and 3 take x. So enter, and now before I graph that, I'm just going to go, and I think standard will be a decent scale, and we have a look. Okay, so along here, the vertical, we know that that's not going to be able to equal 3 because of this. So our domain will be basically x cannot equal 3. Okay, and what about our y? Just from looking at your graph, right, you can see this horizontal line. You could use your trace option if you wanted to, so shift trace, and you can move it along, move it along, move it along. And you'll see that the y value keeps getting closer and closer to 1. Alternatively, let's just put in a really big value for your y value. So what was it again? X take 2. So let's make our x like 1,000. So we're going to go 1,000 take 2 over 3 take x. So 3 take 1,000. And what is that? That's like -1, really close to. So basically that line that it looks like it's not going through is -1. So for us, y is not going to be equal to -1. Normally you can just see you're dividing the coefficients here, right? But we didn't get to that part of our course this year, so fear not. Okay, draw a function that could satisfy the following. So x has to be greater than -1. So that means it's existing for our x values all the way over here. And the range, it's between -2, right? -2, but it's less than 5. So we have to have a function that's sort of in this zone here. Okay, and you could be something simple as, how about you could just go, so less than or equal to 2. Okay, so how about we have an open dot here, right, because that's the coordinate minus 1, 5, so that's satisfying that and that. And we can go anywhere. It can keep going and going and going, so but minus 2 for our y value. So down here to minus 2 we can touch, and then that can just keep on. Well, it can't keep on going, can it? Oh well, you could stop it there. Okay, back to function notation. Okay, and remember this could also be written f(g) of x, right? Fog f(g). Same, all of this is the same. So what I will do is I'll go f of what is g of x. I'm going to pop that in there. So go to my g of x function, so f of 2x plus 2, and then I think we just did a question like this before. So now we're going to our f function, wherever the x is, we replace it with 2x plus 2, so instead of x squared, it's 2x plus 2 squared plus 1. Make sure that you do, like, write your thinking down like this, don't just go straight to the answer. Okay, now remember 2x plus 2 squared, it's that whole FOIL thing that you have to do, or you remember the shortcut to expanding a perfect square. All right, so don't forget to do that. So that's going to be 4x squared. You get a 4x plus another 4x, so that's 8x plus 4. And then we've got our plus 1 there. Okay, so we've got 4x squared plus 8x plus 5. Onward and upward. Ooh, this one's a little bit tricky, isn't it? So we're going to go f of, oops, what happened there? Okay, just fix that. Now I've lost my draw. Here we go. All right, so f of g of x plus 2. So I'm actually going to work out g of x plus 2 first. So go to now my g function. So instead of 2 times x, it's 2 times x plus 2. Okay, a lot of 2's in here, which makes it a bit confusing, but anyway. So 2x plus 4 plus 2. So now we've got 2x plus 6. And that's then what we're going to put in here. So g of x plus 2 is actually 2x plus 6. So now we go to our f function, and wherever the x is, we're going to replace it with 2x plus 6. What do we have to do to it? It says square, so we must square, and then we have to add 1. Okay, expand it nicely. If you have to do the FOIL, do it. And that's going to be 36 plus 1. Oh, I'll write it. I was just going to be sneaky and put the plus 37 there, but there we go. Write it all out. Okay, again, if I've made some silly errors, sorry, but hopefully you're explaining and you understand the gist of. And one last one to do. Okay, g of f of x equals 3 times f of x. Wowza. Okay, so let's go one thing at a time. So g, what is our f of x? Oh, I did it again. Okay, so I just rewrote the functions here because my scroll seems to be having an issue, and there it goes again. Anyway, so g of f of x, so g of x, f of x is x squared plus 1, and that's going to equal 3 times f of x, so 3 times x squared. You're just reading the mathematics and substituting and following what it's telling you to do. All right, so now g of x squared plus 1, go to your g function, wherever x is, replace it with x squared plus 1, so that's the 2 times x, don't forget the plus 2. On this side, we've got 3x squared plus 3. Okay, so let's expand. We've got 2x squared. Oops, now the pen doesn't want to work. 2x squared plus 2 equals 3x squared plus 3. I'm going to get all my x squareds on one side. Normally when I see an x squared, everything goes on one side, but because there's no other plain x's, I'm just going to separate. So get rid of this 2x squared, we take from 3x squared, so that just gives me 1x squared, and then 2 plus 2 is 4, get rid of the plus 3, take 3, so it's 1, and to get rid of the squared, we're going to square root, therefore x can be plus or minus 1? Nice question. So we'll stop it there for that first part, and I'll do a second video for the second part.